Welcome to the third video for grade 11 math exam review for this year. I figured I would, just go through all of these worksheets. Again, these worksheets are from the tvdsb.ca website, so check them out. I'll have a link in the description. I don't think I've been putting the link for the PDFs, but I will. I'm moving on to part 2, functions and transformations. Now, a lot of this has to do with sketching functions, and it's probably, as a tutor, it's probably like one of the most annoying parts, I think. I don't really like having to sketch. I like just computing, and that's pretty much it. So I figured I would draw beforehand these sketches so that they were fine, they were good, and then I would just kind of talk about what I did, and that's just about it. And so we'll start off with number 1. It says sketch the base curve and then describe the transformations. Let me just check. Yeah. Okay, and describe the transformations for each of the functions below. Sketch both the base and the transformed function. So in the first question, we have a cubic function. Okay. And the base function for a cubic is just x cubed, right? You just got to strip away any stretching values, any translation values. So the 2 goes away, the -3 goes away, and the +1 goes away, and you got x cubed. So I drew that. So here I've got, what I usually do is I put 3 points, and then I transform those 3 points, and that's pretty much it, and I just connect the dots, right? So I've got -1, -1, 0, 0, and 1, 1. Okay, these are pretty standard for x cubed. So then I got to figure out what these values are telling me to do. This 2, this -3, and this +1. Well, the 2, right, is a vertical stretch. And what that means is, so basically, instead of 1 over here, right, I now have a 2. And instead of -1 over here, I now have -2. So what I do as a cheating, essentially, is I just switch the values to 2 and -2. I don't even draw a second plot. I just switch the values. That's the first step that I do, right? So let me make this clear. All I do is I switch the values from -1 and 1 to -2 and 2, and that's technically a vertical stretch, right? Nothing happens to the x values yet. Next, I gotta translate 3 over, right? So what I do is I just move the values 3 over, right? So instead of the value occurring at -2 and x equal -1 comma -2, it will now be at 2 comma -2. Great. And now I also translate up 1. Might as well do that in one shot, right? So I move it up 1. And I do the same thing for those for the origin point, and I do the same thing for the point to the right and above it. And that's just about it. Right, so let me cancel out my Steam. Okay, and that's it, and I just connect the dots, and I'm good to go. The next function, once I strip away the negative, right, and that means a reflection, by the way, in the x-axis, about the x-axis, and then if I strip away the 2, the -4, and the -1, I get square root of x. So that is the plot there in B for square root of x. It's just 0, 0, 1, 1, and 4, 2. That's it. Next, I got to look at my transformation. So what the minus there does is it just flips everything over to be under the x-axis where you have negative y values. That's it, right? That's what the minus does. What that 2 does is a horizontal compression. So all you have to do is have all your x values, okay? Now be careful, because here it says -4. What a minus next to an x means is you shift to the right, but be careful not to shift 4 units to the right. What you have to do the correct transformation is you have to first factor out the 2, and then you get x minus 2. It means shift over to the right by 2. So all you have to do is take your values and shift over by 2. So I did that after halving. So if you half 0, right, because of this 2, remember, because of that 2, if you have 0, it's 0. So that stays at the origin. Then I shift over to the right by 2, and then shift down by 1, and I'm there, right? And then I just keep going, right? So then I do the second point, and I'm over here, and third point, I'm over here. And what you can do is you can plug in these x values into this function and see if you get the corresponding y values, and you're good, right? And then now, if I look at part C, I've got minus x minus 3 absolute valued plus 1. Take away the negative, take away the minus 3, take away plus 1, you get absolute value of x. Absolute value of x is this plot. My bad. Absolute value of x is this plot over here on the left in part C. So it's just, plugging in 0, you get 0, right? An absolute value just means, okay, take whatever the numerical value is without the sign involved, right? So if you get 2, it's 2. If it's negative 3, it's 3. If it's negative 4, it's 4. So it just looks like a basically like a V, essentially, which is centered at the origin. This one is pretty easy, and there's a trick. There are actually no flips necessary at all. You do not have to flip about the x or y axis, nothing, because if you factor out a minus sign out of this term, right, the absolute value takes care of that minus sign and makes it go away. So what you should get is the absolute value of x plus 3. Okay, the minus sign goes away completely. So let me write that out just in case. So the absolute value of x minus 3 equals the absolute value of x plus 3 times a negative, and that negative gets swallowed up by the absolute value sign. So it's really just the absolute value of x plus 3 plus 1. That's it. So what that means is take this guy, shift to the left by 3 and up by 1, and then you're good, right? So that's that plot. Now, this one was a little more complicated. Not really, actually, but all I really did was say, okay, it wants me to find and sketch the inverse of this function. So notice I don't have to sketch the original, but I actually will. You'll see why. What we call the parent function. Now, there's one way to do it, and that's switch x and y and solve for y, right? And that will be the inverse function. But the thing is, look, that looks really nasty, and I don't want to bother doing quadratic formula or anything like that. You can't even, you can do it, but I would recommend you don't. Instead, what I did was I completed the square in order to get maybe the vertex and 2 other points. Once I have the vertex and 2 other points to the left and to the right of my function, then I've got 3 points, and then I could just, what the inverse means is you switch x and y, and then you can plot the inverse, and you're done, right? So that's exactly what I did. So I found, this is completing the square, so I'm going to let you walk through that. All the information is there. And what I got was a vertex of negative 3 and 2. And the reason why I have negative 3 is that whenever you have x plus a number, that means the vertex coordinate that goes into the x coordinate is actually a minus, right? So I just put a minus in front. And one way to see that is it's x minus negative 3, right? So I'm not going to bore you with that detail. But the vertex is negative 3 comma 2. And so I've got that guy. Notice also one more thing. You've got, or a couple more things. So you got a minus here in front of the x squared term. Okay, what that minus means is the quadratic, which is a parabola, opens down. Okay, and what this 3 means is if I go to the left and to the right of my vertex value, I will have to go down 3 times. Right, 3 values. So that's exactly what I do here. So I start at my vertex, which is at negative 3 comma 2, and then I go to the left 1 unit, and I go down 3 units, and I circle it in. Then I go to the right 1 unit, and down 3 units, and I circle it in. And double check these guys, right? So plug in, negative 3 comma 2 into the original function, see if I get the right y value of 2. Plug in negative 4 and negative 2 and make sure I get negative 1. I've already checked it. It's good to go. You get negative 1. Now, all you have to do at this point, is just flip the x and y, switch them, right? And that's it. And you'll get these 3 points. So instead of the vertex being at negative 3, 2, it's now at 2, negative 3. Boom. That's this guy. Then, instead of at negative 4, negative 1, it's at negative 1, negative 4. So that's this guy. And then instead of negative 2, negative 1, it's at negative 1, negative 2. Done, right? And then I just That's it. Okay, and there's a line of symmetry, and the line of symmetry is about y equals x. That's because if you flip y and x equals y equals x. That's the mirror, right? So, so that's that. Now let's move on to other questions that I haven't answered. So this should say 3. State the domain and range of each of the following and determine whether it is a function or not. Okay, so right away I can see that this is probably not a function, right? So I've got a domain on the left and a range on the right, and the reason why I know that the left is the domain and the right is the range is because I start over here and the arrows point over here, right? So the domain is all real numbers such that you know, x is -3, -1, and 1. Okay, the range is y all belonging to real numbers such that y is 4, 6, 2, and 5. Okay. The problem is it's only a function if for every x you only have one y. But the problem is, you see, -3 can give me both 4 and 5, so it's not a function, right? Another example of which you don't have a function is a circle, right? Because for a value of 1, I get like -3.5, I think, and +3.5. So 2 y values. Another way to look at it is it doesn't pass the vertical line test, right? So that is not a function. The first one is not a function, but I got my domain and range. So that's part A. Part B, I've got like a square root of x kind of function. This is really hard to see, but I'm assuming that starts at the x-axis and keeps going. So for y values, right, it keeps going above y equals 0. So let's domain first. So domain is x belonging to real numbers, okay, such that x is bigger than or equal to -2, I believe. I believe that's -2 right there. And then the range is y belonging to real numbers, y bigger than or equal to 0. Okay, that means it's non-negative. Okay, so for this function, whenever you're given a plot, just see if it passes the vertical line test, right? It's very straightforward. So it does pass the vertical line test, so it is a function. So again, part C is not a function, and that has, I think that's 3.5, -3.5. So the domain and the range are numerically the same. Like it's going to be x less than or equal to -3.5, less than or equal to 3.5. And the range is going to be the same, but for y values, right? So there's that. Next page. Number 4, find the vertex of each of the following curves and sketch the graph. Oh, okay. I'm assuming that this should be okay with sketching now. I'm just going to find the vertex. The vertex should be really straightforward. So a general vertex form quadratic, and that's what these are, right? Vertex form, and this is called factored form because it's already factored, right, into its multiplicative factors. So a x minus h squared plus k, right? And the vertex is hk. That's the general, right? So in this case, I've got y equals 2x minus 4 squared plus 3. So they've made it really easy for me. So h is 4 and k is 3, so my vertex is 4, 3, right? I don't have to do any magic here. B, I've got a little bit of an issue, right? I can't read off 4, 3, like that's not right. So in this case, instead of x plus 4, right, it's x minus -4, so I can get it to look like that, right? And I can easily read off the result. So the vertex would then be -4, 3. Done, right? And that's kind of what I was alluding to before. Hopefully that wasn't confusing, but I'd imagine it might be. And in this case, to get the vertex, it's not in vertex form, it's in factor form, as I said. So now what you have to do is you have to either convert to vertex form, or you can do a little trick. Let's see what's better, right? Let's see what actually works. And I'll explain it to you if it's not too computationally expensive. Okay, so one way to do it, and it looks like it's going to be nasty, right? So one way to do it is the following. So this is the question. So one of the roots, right, is going to be -2/5, right? So you set this to 0, right? 2x plus 5 equals 0, and you solve for x, you get -2/5. Try that. Then the other one is going to be 8/3, right? So if it's parabolic, then if I've got one root over here, another root over here, right, the x value of the vertex will be the average of the two, right? So all you have to do is take this average, and right away you've got h, right? Then what you do to get k is you plug in that value, that whatever that average is, into your original function, and you get the y value, and that's it. Okay, so I don't know if I should do that. Maybe I'll do h so that we're on the same page, and I'll tell you to plug it in and have at it, right? So -2/5 plus 8/3. Put it all into a common denominator of 15. I get -6 plus 24/15, and that turns out to be 18/15 if I'm not mistaken. So 6/5. 18/15 divided by 3, 6/5. Okay, take that sucker and plug it into here, and whatever you get for k should be the answer. So let me see if I can do it here. That's 12/5 plus 25/5. 12 plus 25 is 37/5. Okay, 37/5 times what is that? 18/5 minus 40/5. Jesus, this is insane. Minus 40/5. Okay, is going to be -22/5. So multiply that in, -22. -22/5. Multiply those together, and that's your k, right? And that's basically the vertex. And then you just got to sketch. The sketching for that, I'm sorry, is going to be nasty. So unless I made a mistake, and I hope that that's actually the case. For 5, solve each using a method of your choice. There's factoring, there's quadratic formula, there's completing the square. So the first one's really straightforward, right? So you got x squared minus 5x equals 6. What that means is that x squared minus 5x minus 6 is 0. Factoring is our option, right? Our good option here. So two numbers that multiply to 6, you can do, let's see, 6 and 1 would work, right? 6 and 1 should work. So 6 and 1, but I need a negative there, right? So the bigger value gets the minus, as I alluded to in a previous video. Check it out. It's actually the video before this on grade 11 math review. Oh, wait, something's not right. Boom. Okay. So let's check that out. So -6x plus 1x, -5x, great. And 1 times -6, -6, beautiful. So x equals -1, x equals 6, done. Okay. And second question, this also might be a factoring problem. So 2x squared minus 11x equals 5. That means that 2x squared minus 11x minus 5 equals 0, right? And 2 is a prime number, so maybe we can factor it if we're lucky. So if 2 is a prime number, the only way you can get 2 with two numbers multiplying together is 2 and 1. right? So 2x, x. Great. And 5 is also a prime number. So the only way you can get 5 is 5 and 1. Now, where do we put 5 and 1? Well, we can test it out, right? So let's try 5 here and 1 here. Luckily, this, I think, works. Maybe not. No, it actually doesn't. It actually doesn't. Because, well, does it? Does it? No. Because if I get a negative here and a negative here, I don't get a negative here, but I do get minus 11x, so that doesn't work. So I don't think factoring works. I think factoring failed. So what we have to do is we have to do the quadratic formula. Now, the quadratic equation, okay, don't be confused between quadratic equation and quadratic formula. The quadratic equation in standard form is that guy, ax squared plus bx plus c, right? So the solution, the quadratic formula, is the solution to this guy. So the quadratic formula is a solution to the quadratic equation. And that's if you're like really screwed, right? And you think there's a solution. So the answer is negative b plus or minus square root b squared minus 4ac. And by the way, this quantity inside the square root is really important. It's called a discriminant, and it's actually in number 6, as you'll see. All divided by 2a. Okay, so if you plug this in and solve, you should get your answer. I don't know if I should do it, really. I mean, negative b is going to be negative of negative 11. That's 11. Plus or minus square root. What is the square of negative 11? That is 121. Minus 4 times 2 times negative 5. Don't forget these negatives, man. They're really important. All divided by 2 times 2. That's 4. Work it out. What does that turn out to be? Well, negative 4 times negative 5 is 20 times 2 is 40. 121 minus 40, brain fart, what is it, 81? So I've got 81, 11 plus or minus square root of 81 is 9, right? All divided by 4. So the answer is, it's either 11 plus 9 over 4, right? 11 plus 9 is 20, divided by 4 is 5, or it's 11 minus 9 over 4. 11 minus 9 is 2. 2 over 4 is 1/2. Done, right? So we get our answer. I think that could have been factored. I might have made a mistake, which is definitely possible. Excuse me. 2 plus 3 over x equals 2x plus 3 divided by x minus 1. Wow, solving this doesn't look like a piece of cake, but it should be fine. What I do is I multiply both sides by x and x minus 1. So, you know, if I multiply this guy, right, by x, so you got to multiply both sides by x, x minus 1, both sides. So this guy is only going to take an x minus 1 in the top because that x kills that one off. So it's going to be 3x minus 1. Cool. This guy is going to take care of that x minus 1, so I only get an x. So I put that over here. Remember, brackets are really important. And here I put both guys because nothing kills anything off, right? And then I have to expand and simplify, right? So let's do that. 2x squared minus 2x plus 3x minus 3 equals 2x squared plus 3x. But you know what's beautiful about this? This 2x squared will kill that 2x squared off. All I have to do is take away 2x squared from both sides and I'm good. And then that 3x will kill that 3x off. And so what I end up getting is that negative 3 equals 2x, right? Because this thing can go over here and I get positive 2x. So 2x equals negative 3, which is left over. And then you get x equals negative 3/2 and you're done, right? Boom. And last but certainly not least, so there's only one solution to that question. So last but certainly not least, number 6. Okay, and this part is really straightforward. And I'm going to demonstrate it to you. In the quadratic formula, if b squared minus 4ac is positive, how many real number solutions are there? Don't worry about real or imaginary for now. How many solutions are there? What if it is equal to 0 So what if b squared minus 4ac is 0? And what if it is equal to a negative? Okay. Let's go back to the quadratic formula. Okay. Okay. Now, let's say that this thing, right, is 0. What's the square root of 0? The square root of 0, right, is 0. So what this turns into is negative b plus or minus nothing over 2a. What's something plus nothing or something minus nothing? It's itself, right? So this solution turns into just negative b over 2a. But b is some number, a is some number, right? And so that equals only one thing. So if this guy, the discriminant, is 0, you get one solution. Okay, one solution. Now, if it's positive, like if it's like 5 or 25 or something like that, then it's going to be a square root. Like let's say if it's 25, then the square root of 25 is 5. So it's going to be negative b. It's going to be negative b, right, plus or minus 5 over 2a. That's going to be two things, right? Because it's going to be negative b plus 5 over 2a or negative b minus 5 over 2a. So that's two solutions. So if b squared minus 4ac is greater than 0, you got two solutions no matter what. I don't care what it is. But if it's negative, right, can you take the square root of a negative? I want you to grab your calculator and do the square root of negative 2. You can't do it, right? So if b squared minus 4ac is negative, that means you've got no real solution, okay? And so just to go into it, you can either have imaginary numbers or real numbers. In the case, if you were asked if there are any solutions, right, and it doesn't say anything, I would assume real solutions. So like numbers that you can get out of your calculator. Otherwise, yeah, I wouldn't assume. Yeah, so I mean, what's nice is they tell you how many real number of solutions are there, so very, very specific. But if they just say how many solutions there are, just assume they're talking about real number solutions in this context because they're talking about the discriminant, and that usually implies this sort of framework. So that's functions and transformations. Thank you so much, and I'll talk to you guys another time. And I'm just going to do radicals next time, so probably like tomorrow or something like that, I'll do radicals. So that'll be fun. Hope this was informative. Peace out.